The format of this panel will be a 5-minute introduction of each of the panelist groups, who are Yihui Xie from our studio, Shirley Wang from Brigham Hospital Harvard Medical School, Jeffrey Morris from University of Pennsylvania, and Patty Liu and Joseph Friedman from the UCLA and the Institute of Health Metrics and Evaluation. I will give the floor to Yihui Xie, and I will give you a notice when the 5 minutes are up.
All right. Hi, everyone. This is Yihui. I want to briefly introduce some of my work related to reproducible research. In case you want to follow my slides, slides are available here at bit.ly/COVID-down. All right, so to be honest, I'm not really an expert on open data, so I'm not going to talk much about that today. I am a software engineer, so I'm all for open code. So as you can see from my GitHub page, I have worked on several open source R packages. So the first one that I worked on was called Knitter, and I started working on that package in 2012. And my original goal was to make it easier for myself to do my own homework assignments when I was a PhD student at Iowa State. And later it turned out that Knitter was also very useful for reproducible research. And especially when Knitter was combined with a language called Markdown. And it became even more popular. And then R Markdown was born. And I think that is why I am here today. So in case you don't know much about R Markdown, here is minimal examples. Basically, R Markdown is a plain text format. So in this document, you can have some metadata, such as like the title or author date of your document. And then in the body of your document, you can write some narratives and mix the narratives with some code for computing. For example, here I have a code chunk to fit a linear progression, and I will draw some plots. So besides the code chunks, the other thing that you can mix into your document is the inline code. So after you have a document like this, which is a mixture of narratives and code, you can actually call a function or click a button in RStudio to compile that document. So we often say knit that document. If you knit R Markdown, the result will be a Markdown document. So that was the original source document, and this is the Markdown output document. So you can see from here that the difference is that the computing was done, the graphics were generated and inserted in the output. And here the inline code B1 was converted to a number, negative 17.58. So that is how a document is knitted. So when you knit it, you get the output document. So everything is generated dynamically instead of like copy and pasting. So if you are interested in some of the technical details, R Markdown basically is built on top of Knitter, which is for literate programming, and Pandoc, which is a tool to convert Markdown document to other document formats. So some people might be more interested in this cute cartoon, which illustrates this process. You have an R Markdown document, and it goes through Knitter and goes through Pandoc, and finally you've got a beautiful report. So it is related to reproducible research, but I have to remind you that using R Markdown only implies that reports might be computationally reproducible. So I have emphasized two places. It might be reproducible because reproducible research is really hard. And there are so many factors that can affect the reproducibility of your reports. And the second emphasis is that using Markdown makes your document computationally reproducible. And there are also other levels of reproducibility, and I guess some other panelists will mention. So R Markdown only solves the computational problems. So the major feature of R Markdown is that the Markdown language is really simple. It supports some common document elements like section headers, paragraphs, lists, tables, figures, citations, and so on. I often tell people that Markdown is just so simple. If you cannot learn the basics of Markdown in 5 minutes, I would just give you $20. And so far, no one has claimed that $20. So hopefully it's really simple. And Markdown can be converted to a variety of output formats, such as HTML, LaTeX, PDF, Word, PowerPoint, LaTeX Beamer, HTML slides, ebooks. And there are also many types of applications that you can write reports, journal papers, books, websites, create presentations, resumes, dashboards, and so on. You can go back and check out these 2 examples, rpubs.com and bookdown.org, to see many applications based on R Markdown. Over the years, I have written a few books based on Knitr and R Markdown. So except the first one, the next 4 books are totally open source and free. You can read them free online. And just to show you a quick example of some of the potential of Knitr and R Markdown. So basically for this code chunk, you just specify a chunk option in the chunk header, and then you get an animation easily from this R Markdown code chunk. So yeah, so creating a Pac-Man, in my eyes, is one of the very few legitimate use cases of parts. And I also want to remind you that R Markdown is not only for R. You get other types of languages in the document. For example, you can insert a Python code chunk, you can use Julia, you can use SQL, C++, and so on. I probably won't have time for you to go through this example. I will let you play with it later.
So thank you so much.
Yeah, thank you.
Thank you so much for your introduction. Next up is Shirley Wang.
Hi, I didn't prepare any slides for this morning, but I thought I'd just spend a few minutes talking. So I'm an assistant professor at Brigham and Women's Hospital, Harvard Medical School, and lead epidemiologist for the FDA Sentinel Innovation Center. And a lot of my work focuses not so much on open data or code, but on reproducible research. So my field of pharmacoepidemiology focuses on making causal inference about the safety and effectiveness of drugs in large populations using routinely collected electronic healthcare databases like insurance claims or EMRs. In other words, we focus on generating real-world evidence, and this can provide key insights on medical product safety and effectiveness for regulators, payers, and prescribers. But poorly designed database studies have led to some negative generalizations about the credibility of real-world evidence as a whole, instead of focusing on what tools we need in order to distinguish the valid and robust methodology from that which is less reliable. And you may have noticed some high-profile retractions and problematic real-world evidence studies related to COVID being elevated in the media over the past few months. But implementation of a database study often involves substantial, complex transformation of source data to create the study analytic cohorts that are appropriately temporally anchored. And currently, the ambiguity in reporting on study implementation has become one of the most frequently mentioned barriers for healthcare decision makers against use of real-world evidence. And this is because it's really hard for reviewers to assess if the scientific choices behind the findings are valid when they can't tell what those choices are. So my interest in appropriate implementation of complex methods for real-world evidence studies has led to efforts in open science, where I've been working on measuring and improving the reproducibility and robustness of healthcare database research. A couple of years ago, I co-led a joint task force for the International Society of Pharmacoepidemiology and the International Society for Pharmacoeconomics and Outcomes Research, which was focusing on improving the credibility of real-world evidence for healthcare decision-making by increasing the transparency of the processes that are used to conduct research studies. And currently, I'm on a steering committee for a transparency initiative that's focusing on streamlining the processes and reducing barriers and increasing incentives to encourage routine registration of hypothesis evaluating real-world evidence studies to try and parallel the requirements of randomized clinical trials. I'm also leading a second joint task force, which is focusing on developing a standard protocol template that's designed to communicate key study design, analysis, and implementation parameters in tabular and visual formats to try and minimize prose and potential for misinterpretation. The goal is to enhance communication and facilitate validity assessment for regulatory health technology assessment and other healthcare decision-making that's informed by real-world evidence studies. The last thing I want to mention is that I currently co-direct the REPEAT initiative, which is a nonprofit program with projects aimed at improving transparency, reproducibility, and robustness of evidence from healthcare databases. So in our large-scale reproducibility study, we're almost done replicating 150 peer-reviewed real-world evidence studies using the same source data and trying to apply the same methods to recreate the study cohorts and do the same analyses as reported by the original authors. So far, the relative magnitude of effect sizes between the original study and the replications that we've been doing has been pretty spot on, with a median relative magnitude of 1 and an interquartile range between 0.9 and 1.1. However, the full range is really wide, with the original effect estimate anywhere from 1/3 to 2.5 times the size of the replication estimate. But I do believe that with coordinated effort from stakeholders, the bar can be raised. Minimum standard expectations for clarity and communicating about real-world evidence study implementation can be improved, and all of this hopefully resulting in more replicable results, more efficient evaluation of validity, and also more effective evidence-based decision-making.
Thank you so much, Shirley. Next up is Jeff Morris.
Okay, let me know. Okay, great. Yeah, so I'm a professor and director of biostatistics at University of Pennsylvania, and have got involved in a number of different COVID-19 related projects there. And so I'm just briefly going to talk about just one modeling project I'm involved in, and then I'm going to talk about a COVID data science blog that I've worked on, and talk about some issues with data transparency that I think are very important during this crisis. So briefly, I just want to mention a modeling effort that I'm involved in with Policy Lab investigators at CHOP, and our goal is to build hybrid statistical epi models to identify factors predicting cases and to generate county level predictions and identify emerging hotspots. So this data that's used for this modeling integrates a lot of different public sources of data together with the goal of trying to identify these factors and get accurate projections. And so the modeling involves first estimating the effective reproductive number for each county, and then building a model to relate that to many different environmental and demographic factors at the county level in order to discern what's affecting the spread. And so this model's goal is to get weekly projections of future case counts to try and help policymakers identify where the hotspots are so they can intervene. So it's a type of modeling that's very heavily reliant on the accurate case counts. And so this has I think made a strong impact where the Deborah Birx and the White House Pandemic Response Team is using this to try and identify which areas to intervene. So that's an example of where the data needs to be reliable. And also another thing I want to mention very briefly is I've spent some time during this pandemic on this blog page called coviddatascience.com. And my goal there is to basically use my perspective and way of thinking as a statistical data scientist to try and evaluate the emerging information about COVID-19, filter out the biases, combine this information together, and identify key insights in what we're learning about the pandemic and try and communicate them in an accessible, balanced way. And so I've covered a wide range of topics in the pandemic, including different mitigation strategies, evaluating modes of spread, treatments, vaccines, testing strategies, discussing the limitations of each data type and issues of measurement error, and also weighing in on important decisions like community and school openings. And so part of what I tried to do is just bring our perspective to a sort of a general venue that the public can understand about how these important quantitative issues come into play in our growing understanding of the pandemic. And so I have a number of key themes through this blog site, including cutting through political and narrative-based thinking in order to evaluate the information that's there and help people understand what are the key factors that are emerging and what bits of information that are being put out there in the media are really solid, have solid scientific evidence and a low level of uncertainty, and which things might have more uncertainty and which things might be false information, trying to help people sort through that. And a lot of it involves kind of trying to find a middle ground between two sides that appear to be either minimizing the crisis or perhaps exaggerating certain aspects of the crisis and losing perspective of other aspects of society. And so one of the themes that I've kind of hit on a little bit in that blog is this idea of wartime science, that during a time like this, we can't really allow science to proceed at the same pace that it usually does. So we have to somehow get information faster because of the millions of patients that are having to be treated now. But yet we have to try to evaluate this information quickly, but yet we also need to maintain rigor and care to make sure that we're learning properly. So it puts us in a very difficult position. But I think that statisticians and data scientists have a major role to play in both of these processes, in making sure that the science being done is rigorous and the long-term studies are done as carefully, but also trying to help evaluate the short-term accruing information and making sure that our perspective is heard in terms of what information is reliable or not. And so two specific issues that I see as very important in the topics of this conference involve data sharing and transparency. So one of them is documentation of data for journals. And so a lot of you know about the paper, the May Lancet paper by the Surgisphere group on hydroxychloroquine that was subsequently retracted. But somehow it got through the review process and was approved, even though if any of us really read through the paper and checked, it was very clear that the data could not be authentic, that they purportedly assembled data from all over the world, almost tens of thousands of records from hospitals all over the world with very little missing data, and pulled together in 3 weeks with an author list of 4 people. And there were certain data anomalies that were very clear in the tables that, for example, number of COVID-related deaths in Australia that were listed were greater than the total number in that country at that time. The number of African cases in their database would suggest that every single COVID patient in the whole continent was basically in their database. And it reported, Jeffrey? Oh, yes.
Your introduction time is up. I'm going to thank you so much for that.
Okay.
I'll need to move on to Patty Liu and Joseph Friedman.
Okay.
And we will address some of these things back in the questions Q&A.
Okay, thank you.
Patty and Joseph, you have the floor.
Hi there. Good morning, everyone. Let me just share my screen here. All right. Hi, everyone. Good morning. My name is Patty Liu, and I'm joined by Joseph Friedman. We're current medical students at the David Geffen School of Medicine at UCLA, and we're both former fellows at the Institute for Health Metrics and Evaluation. And we're really excited to join in today's conversation on data transparency and reproducibility. And this is actually the impetus for the creation of COVID Compare, which we're both the lead authors for, which is a predictive performance framework for international COVID mortality forecasting models. So just a brief introduction of COVID Compare. I think we all can understand the importance of COVID forecasting models, both in terms of public policy and public health resource mobilization in response to the COVID pandemic. However, to date, there are hundreds of models that have been released, each with varying structures and assumptions. And moreover, several models have fundamentally changed their structures over time. And so that kind of begs the question of who should we look to for the most accurate estimates? I think early on, there was a bit of public and academic debate about the structure and assumption of models, which still continues. However, most of the comparisons were kind of one-off, cherry-picked, and not comprehensive, and thus the conclusions you can draw from those comparisons are rather limited. I think the Reich Lab at UMass Amherst did a fantastic job of kind of organizing and collating now a repository of 30 plus models for the United States. This allows for a visual comparison of what the models are saying and has allowed the Reich Lab to create an ensemble model from kind of the best of these models. However, we feel that it falls a little bit short of doing formal, like a formal model comparison to actually assess the predictive performance of each of these models. And so we felt that there was a need for an ongoing, comprehensive model performance comparison, and that was the goal with the creation of this framework. And we believe that this has kind of a twofold in terms of utility. One, I think most important for now is to help policymakers and public health officials interpret the validity and performance of current models. And second, I think there's a lot of interesting work that can be done retrospectively to assess, given what data we had at a particular point in time, given our assumptions, what were the effects of these assumptions in actual model performance. And this will allow the research community to better understand and inform future epidemic and pandemic modeling. So the main product of this effort was a repository of code, which you can access here, that has a set of ready-to-run code which reproduces and updates a systematic review of forecasting models from PubMed and medRxiv, as well as other sources. It collates all model versions that are publicly available and downloadable, standardizes them for comparison, and ultimately allows us to do things like compare the predictive performance of the magnitude of cumulative mortality and timing of peak mortality, two key kind of metrics that have been useful for policy and public health officials. And to date, we include 8 models that have publicly available historically versioned estimates of multinational forecasts. And we've reviewed close to 400 forecasts. And the models that you can see are below. There are 3 from IHME, 1 from Delphi, 1 from Los Alamos National Lab, from Yuangu, Imperial College London estimates for low and middle income countries, and we recently added a new model from USC. And we invite anyone who knows of similar models to submit a ticket to our GitHub, and we would love to include that in this comparison framework. And just briefly, I won't go into too much detail, but this is kind of what we're able to do with collating all of these data together and to create a comparative framework for model performance. So this particular view allows us to assess what models are currently saying about the cumulative mortality in the United States. In the top left, we see this displays the most recent model version for each of these models. Down in the middle here, if you can see my mouse, this is all historical versions overlaid for each of the models. Down below is all the model errors compared to the JHU data, which we're calling truth. And in the top right, we're able to calculate statistics on modeling performance by month and by week of forecasting. This is another view that allows us to compare the peak timing, or what forecasts are saying about peak timing. Here, each model is overlaid, and each circle here is essentially what that model version at that time said would be the peak in this particular location.
Patty, thank you so much. That is time. We will now move on to Q&A. The format of the Q&A will be I'll just ask a question, and if any of the panelists feel a particular interest in answering that question, you may speak up. If not, I will try to choose the best person to answer that. and we can have the full answers. So the first question I'm going to ask is with regards to the difference between academic and software standards. Victoria Stodden once made a claim that virtually all published discoveries today have a computational component, and continues to say that there is a mismatch between traditional scientific dissemination practices and modern computational research processes, leading to reproducibility concerns. We currently live in a time where any change to a code base can be reported using Git. All logic can be redocumented with R Markdown or Jupyter notebooks, and entire environments can be reproduced by using Docker containers. Currently, software practices seem to be perfect for reproducibility, but our academic publications and institutions utilizing these. Is there indeed a concerning mismatch between the scientific community and the computational community? And if so, how can we change this?
All right, so yeah, in terms of the journals that embrace reproducible research, I am aware of two. One is Journal of Statistical Software, and the other is Biostatistics. I know some JSS papers were written in the RNW format, which is one of the formats that Nature supports. And in recent years, JS has also started to accept papers written in R Markdown, which is really, really great in my eyes. So actually, when I was young and naive, I had some ideas on creating a new reproducible journal, which I wrote down in a blog post in 2012. If you have my slides, you can click on the link to see the ideas. So after I became older and still naive, I realized that running a journal was not as easy as I thought. But I'm still interested in this and in doing this. I just don't know when I may have the time. So I would take biostatistics as an example. Actually, I think Roger Pan will be a much better panelist than me talking here. Actually, he published a note in Biostatistics 11 years ago, in where he proposed that journals could have an associate editor for reproducibility, AER, so that AER could consider three different criteria when evaluating the reproducibility of an article, which is like, is the data available for this journal paper, or is the computer code available to reproduce the results? And the third one is, can the associate editor actually run the code to reproduce the results? And I think that was quite novel at that time, thinking about 2009. I'm not sure how journals are doing nowadays, but I think this early proposal was very useful and helpful. So for the second question, how can we change this mismatch? So I have two ideas. So the first one is that I feel, from my experience, when I visited some departments, especially the stats departments, and I feel most students are very comfortable with using tools like R Markdown or Jupyter notebooks to write their own homework assignments or data reports. Personally, I just wish more professors could encourage their students to embrace modern technologies for reproducible research, even if those professors don't use these tools by themselves. I also highly recommend that you watch the talk from, by Professor Frank Harrell for graphical clinical trial reporting. And in that talk, he just showed that he was very open-minded in my eyes. And he just embraced reproducibility so quickly. I mean, he can change his tools so easily. So I have heard an extreme example earlier this year, and I was quite shocked that in a certain university, and there was a graduate student who was my friend, and he told me that he wrote his thesis in R Markdown, and his advisor was quite unhappy with that. And his advisor thought, oh, you wrote your thesis in R Markdown. I have never heard of R Markdown. I always write things in a Word or LaTeX. And his advisor strongly discouraged this student from using R Markdown. And I was very unhappy on hearing that. I just don't wish this to happen in other institutes. The second idea is that I mentioned JSS and biostatistics before, and actually the R journal also accepts R Markdown. If you convert R Markdown to LaTeX and submit your paper. So this is actually made possible through our package named Articles. So articles without A, articles. So I don't mean to self-promote too much here, but the articles package was designed to support journal papers. So if you're interested in, you can go to the GitHub repository and check out that package. I think this might help at least in academia to embrace reproducibility much faster.
Awesome. Thank you so much, Yihui. And before we move on to the next questions, I was wondering if anybody else would like to chip in.
Yes, I'll say a word or two. Yeah, I think tools like R Markdown are great, and I think it's easier to get the scientific community to start using them. But I think the key is trying to figure out how also to improve the reproducibility across the wide swath of scientific journals. And so I think it does require a culture change for them to make more rigorous requirements. And I think a lot of, especially the top journals, have made more requirements, at least in terms of data sharing, but in terms of sort of sharing scripts and code and analytical reproducibility, I don't think they've gone as far. So I think, you know, it's an open question how we can help change the culture, but I think providing tools, and that's why I think R Markdown is great, and I think figuring out ways to expand the tool set to go to all of the analytical packages that people use, even non-statisticians in their work, I think that would go a long way, as well as also just communicating clearly what the expectations are, at what level of documentation and reproducibility is expected.
Could I jump in?
Of course.
I think increasingly in pharmacoepidemiology, we've been turning to use of reusable, semi-automated software tools and analytic platforms that make our study design, implementation, and analyses computationally reproducible. And of course, researchers still need to use de novo code for various reasons. But in these situations, when we do have the availability of shared code to enable computational reproducibility, I think there's still a large gap often in communication and documentation about what scientific decisions are actually being implemented to create the analytic study population, much less analyze it. And all of this is detail that would be necessary for independent replication of results. And those decisions, the intent of the investigator, are critically important to assess validity of the methods for the question being addressed. So it is important to be able to run a script and get the same result each time, but it really needs that clear, concise documentation about what the intent is, what the scientific decision about design or analysis is, because it's not that difficult to rerun code once you have it, but it is difficult to read another person's code. And if the reader or reviewer can't understand it, then communication hasn't happened.
Thank you, Shirley. I would actually kind of like to use that to segue into another question. So most fields actually provide guidelines on how to effectively and efficiently report on study design, data acquisition, and model creation. But these guidelines are often subject to interpretation and can vary wildly from different researchers. Coming off of what you just said, Shirley, are there any rules of thumbs that researchers can use to provide sufficient documentation without dumping an entire logbook?
Well, it's actually sort of what we're working on developing for real-world evidence studies, at least. We recognize that there's a lot of different interpretations of existing guidance, which tends to be a bit broad in general to cover a broad base. So in some of the joint task forces and multi-stakeholder collaborations that have been happening over the last few years and are ongoing right now, we've tried to reach consensus on some of the, at least for our field, key study implementation details that are necessary for both reproducibility and validity assessment. And we're developing a structured template that could be used for planning, implementing, and then sharing for reporting on the study implementation. So it is stuff that we're working on to try and clarify specifically what needs to be shared, like set clear expectations for communication, reduce misinterpretation, and help reviewers quickly find key information.
Thank you. Would anybody else like to chime in on that?
Yeah, I can talk a little bit. As I said, my perspective is very narrow. I mean, I'm always talking from the perspective of computing. So for computing, ideally, you shouldn't need any guidelines for other people to reproduce your results, because you would want to automate the computing as much as possible. So I wrote a blog post last year titled, "Ideally, I hope to simply copy and run your example." In that post, I mentioned that words can be ambiguous and code is precise. So, but I admit that that's only the ideal case. Practically, it's impossible to automate everything. Even in computing, there are tools to overcome this problem, such as Docker. But to be honest, even I don't use Docker myself. And if you ask people to install yet another software tool, there will always be resistance. And another solution to this computing problem is to do the computing on the clouds. For example, you can create an RStudio Cloud project, or create a GitHub repo and combine that with Binder. If you have not heard of Binder before, you can go to their website and check it out. So basically, this is the cloud computing infrastructure. And the advantage of this is that people won't need to install anything locally, and they don't need a lot of instructions to install this, install that, and click this button or run that code. So everything is on cloud. You just automate everything on cloud and set up the necessary tools for them to reproduce your results.
Thank you, Yihui.
Yes, this is Jeff. I'd like to make some comments as well. I think in terms of acceptable documentation, I think our statistical community needs to take a more active role in trying to help inform and clarify what are the specific items of documentation that are important to make clear. If there's vague guidelines, it's very easy for authors to just provide shallow information, but then the types of questions that we would want to ask are not answered. So asking questions about the experimental design or source of the data collection for observational studies that would inform us about potential sources of confounding, questions of how many variables they looked at, to think in terms of multiple testing and hidden multiplicities, in terms of looking at explanatory factors, and even modeling decisions that were made, how those were made, and what other models were considered, and questions of training and validation of models. Many times there's not enough specifics to get a sense whether certain aspects of the data were used in the validation data, were even used in training the model. So just not enough specifics. But I think we need to help provide guidance about some of the specific things, specific questions that need to be asked, so that the authors, can provide enough information to answer the key questions. And I know I've talked with our editorial, assistance group about what some of these are, so they can help other researchers whom they're helping write the papers make sure that information is included. But I think we need to figure out a way as a statistical community to communicate with the broader scientific community to help them understand what are the key issues that need to be crystal clear, to make sure that the common errors that lead to irreproducible research aren't made.
Thank you. And I would also like to bring up something I noticed going through Patty and Joseph's Twitter feeds. When they were working on reproducing these models, or working on these models, one of the authors actually reached out and said that their model had some changes in assumptions, and actually communicated that stuff. When you were working on your project COVID Compare, what was your experience in the documentation of actually implementing these models?
Yeah, I can comment on that. I think one of the best things about putting the framework on GitHub is it provides a way for everyone whose work is being analyzed to chime in. with like a regular meta-analysis, which authors just do separately in a static way, and then, publish in a journal, like you wouldn't have a chance for that kind of back and forth. And so I think one of the things we really appreciated is we were able to put the whole framework on GitHub. We release it on medRxiv, which means you can update it in an ongoing fashion. And I think it's this interesting example where a regular journal publication wouldn't really have done a lot of these things for us, right? Like because of COVID, we wanted to get this out as soon as possible. And so exactly, like one author reached out and they said, well, you had a different assumption about the way you processed our data, and it's introducing these very small errors, and we were able to actually change our framework. And similarly, a different modeling group reached out to us and said, hey, I think, we have this new model, and I think actually we now fit all of your requirements. And we're able to work with them, and they actually have their public-facing data, so it would fit really nicely in our framework. So I would say it's been really positive.
Thank you. So there's been a lot of chatter in the Q&A and chat focusing on data in general. So I'm going to make this into a two-part question, where the first part is what should researchers consider when making this data, data available to others, if they can publicly make the data available to others? And what about situations where the researcher does not necessarily have an appropriate infrastructure to store the data publicly, being maybe just a giant cloud environment? And on the inverse of this, how do we know when we can trust the publicly available data? And I think I'm going to point to Jeffrey for this.
Yes, I think the key thing, I think it's a difficult decision. Journals that are trying to figure out whether to require sharing of data, it's obviously best when the data can be shared, but there's many reasons, like the question mentioned, when you can't. So I think the key thing is, again, comes down to a question of documentation of the data, of the sources of data, how it was collected, so that people can assess whether they have any issues about either the accuracy of the data, or more commonly, like I was mentioning in the previous question, potential biases that might arise because of how the data are collected. So I think, the answer for how to do this is contextual. Like there might be some settings where you require the sharing of data. And then I think what's really important is clarity in terms of the format of the data sharing, and specifically the documentation. In other settings, it might not be reasonable or possible to ask for that, but I think that the minimum information required should be made clear and shared. So, I mean, one example of the type of thing that's important is when there's complex data that require many processing steps to get to the analyzable form. Those ideally you'd have, in R Markdown or something that shows what they all are and people can play with them and change them. But even if that's not possible, documenting what those steps are is very important. Many times is not done. And another issue, like the case study that I was mentioning about, when I was talking before about the Lancet paper, if they had just asked for a bit more documentation about where this data came from, they were claiming to get data from hundreds and hundreds of hospitals all over the world, many different countries, every continent. All these places supposedly had EMRs and had the software package that this company was providing. And for them to pull all of this together in a matter of 3 weeks and analyze it and write the paper and publish it was obviously implausible. But if they would have asked questions just to document where the data had come from and how it was processed, it would have been very clear that they couldn't answer those questions. And what they did was hide behind a claim of propriety. They said, well, it's come through our proprietary data, all the collaborators, we're not free to share who they are. And they just hid behind that, and the journal accepted that, where, it might be clear that if a company collects data from sources, they might not be able to share that data, but certainly there should be a level of documentation that they could provide and that the journal should ask for. But obviously the system failed in that case. And I think, with the increasing availability of EMR data and the very importance of our ability to pull this data together and analyze it and learn so much from it. I think it's going to be very important for us to figure out a way that we can document things so people can assess the reliability, to prevent bad actors from being able to publish papers on, data that's not authentic, which is the one extreme. But I think the more common problem is just inadequately documented data that has problems that affect valid interpretation. But there's not enough information in the publication for the reviewers to assess it, or for the scientific community or the policymakers to assess it. So they're just going to look at the abstract and take the conclusions and move forward, and those questions aren't asked. So I think it's a really difficult but open question to figure out what is the minimum information to document these things. But I think a key thing that's definitely true is that our community needs to be actively engaged in that process and making sure that we have our perspective heard, because I think our expertise and experience equips us to understand what are the most important questions to ask, not just the vague questions, but the detailed questions that make a big difference.
And Jeffrey, you brought up a good point that I would like to segue to a question to Shirley. There's responsibilities on both sides with regards to how we expect reproducibility and actual good work to be. You mentioned that it was kind of on the responsibility of Lancet to actually know what was good data and how to review good data. That implies an idea of good habits, and what that's obviously, if they were given the code and they just ran, if they were given the data and just ran code, it would have worked technically, but they didn't necessarily have the tools, or they didn't use the tools to actually ask and ask what are good habits. So on both sides, whether you're creating research, and this is aimed towards Shirley, on both sides, whether you're creating research or you're reviewing research, reproducibility seems to be the mindset of an environment that promotes good habits. But what are these good habits, and how can they be encouraged within the community, both the reviewer side and the researcher side? How can we encourage better habits?
It's a really tough question. I think a lot of it is going to be changing culture and expectations. And I think that's where a lot of this current joint task force effort is trying to bring in a lot of stakeholders, from decision makers, from researchers, from industry, from all of the stakeholders that are involved in generating evidence from at least secondary healthcare data sources, because it is complicated and there are many steps of different from data transformations from the data holders, from the researchers, and then finally the results. And what we're trying to do is become more specific, because when we have these general recommendations that everyone can generally agree on, but are interpreting it differently, that doesn't really get us where we need to go. We need to be very, very specific about this is what we're expecting at this stage. And if we can move toward more consistent use of registration or use of a structured template where you communicate those key details about how you get from the source data to the data that you analyze. I think, I don't know how exactly, but if we can move towards more and more stakeholders adopting this can help sort of change a trickle-down effect, I think. And I think there's been a really strong focus on this from many, many different groups, including from EMA, the NCEP group, EU PASS, and right now there's another, the International Council of Harmonization for Regulators. I think this is probably the top bar where the regulators are saying, we need to see this. If they set the bar there, then I think other people might sort of set the bar at a higher level as well, and have that trickle down effect.
Thank you. And continuing on the theme of data, and I'm going to aim this towards Patty Liu and Joseph Friedman. Sometimes data is private, and while the research can be made public, certain data sets, whether it's because of reasons of personal identifiable information, or whether it is it is data that the researcher paid for explicitly and for whatever commitments can actually expose the data. What are the options for reproducing models where the data isn't necessarily made available?
I think that's $1 million question, and ultimately it has to do with the power structures in academia, right? I mean, people are incentivized to not share their data because, I mean, it's good for science if they do, but unfortunately, in many cases, it can be bad for their personal career. You know what I mean? People have to think about their own publications. Are they going to get tenure? Are they going to be able to provide for their families? And I think they're very like important implications about data sharing that. So I think if we want people to share their data, we have to incentivize them to do so and create an environment that supports it. And so even like, for example, I've seen in some journals, even if you can't share all of your raw data, even just little things like being able to share the data that go into all of your figures, like sort of sharing the final modified data, the sort of summarized data, I think can be massively helpful. Like if you're, for example, if you're working on a systematic review, like not having to go in and like rip all of the data points out of the graphs, you know, like just very simple things I think could be incentivized. And I would love to see some sort of formalization where you can actually put on your resume, like, I have put out into the world these data sets and I maintain them and I am sort of an expert on these things. And in some ways, I think there are some limited ways that does happen, but I haven't seen it in any kind of systematic way. And I think that that's where we have to start, right? I mean, there's many times people can't share data because of the data use agreement, and that's more of an upstream problem. But like, there's also many times where the journal says, if you want to share your data, you can, but it's not required, it's not obligatory. And I think that's the most common thing that I've seen. And you know, we just have to incentivize in that moment. It's going to take an extra 2 hours to prepare the data and release it and put it on a platform. And the person is busy, and they just need to feel like there's some kind of incentive, you know, because unfortunately, I think if you don't incentivize something, it's unlikely that it's going to happen.
Could I also add that in addition to the trickle-down effect, there's like the incentives, at least in psychology, there's the open science framework where increasingly journals have been having badging, where you provide a badge if someone provides open data, another badge if they provide open code, another badge if they do other reproducible practices, and that's something that could be adopted more widely outside of the psychology community.
There was a concern in the Q&A that a lot of people that we might be underestimating the amount of time and expertise needed to move forward with using software tools, and a lot of tools a lot of research fields aren't necessarily code heavy. And while you can make tools like R Markdown as friendly as possible, and yes, you could learn it in 20 minutes or less, there are other points of concern with reproducibility. Like there's still a upward battle with learning tools like Git, even learning how to code in R, and even understanding what is actually going on under the hood, like to make changes in the HTML document. What are your thoughts on fields that aren't necessarily code heavy, but that are still trying to create reproduce things with tools?
I don't have a good idea on that, but I agree with the person who brought forward this problem. As I have probably implied several times in my talk, I have really been picking the low-hanging fruits, which is to design the tools. You know, dealing with code and tools, I mean, as a software engineer is much easier than dealing with people or convince people of using these tools. I don't have a good solution. Sorry.
Thank you. And we have one more Q&A. This is just a general question. Are there any efforts, like Shirley mentioned that there was a badging system, but there is the idea that registerable and citable articles that have a DOI are essentially the current currencies in academia. Are there any efforts to make code and data registerable in DOI with the DOI?
At least at Harvard, we have a Harvard Dataverse where I have put data in code and I get a DOI, which I can use as a citable resource. I'm sure there are other platforms out there as well. If you go to the Open Science Framework, I think you can register a lot of items, including your protocol and all of that, and have that be a citable resource. Just look up OSF, Open Science Framework.
Thank you. And we're almost at time, and I'm going to allow everybody 2 minutes to say any departing notes or comments? Yihui, would you like to start?
Yeah, I just want to say that if there's anything that I can do to help enhance reproducibility in terms of the software tools, please feel free to let me know. Thank you.
Shirley?
I don't think I have anything to add to what I've already said before, but feel free to reach out if anyone has questions or comments or feedback.
Jeff?
Yes, I think, I'd just reiterate that, our profession needs to put time into taking leadership on these issues. They're difficult, but also just to mention, there's a whole nother set of sort of data transparency issues with the COVID crisis that we didn't really discuss, but that are important for us to think about in terms of how municipalities report their data and making sure that this data reported is accurate. So again, this is another issue that I think we need to engage to make sure that measurement error and other biases are well understood, and that the policymakers take this into account in the data they accrue that decision makers use to make the important decisions in management in this crisis.
Joseph and Patty?
Yeah, I guess I would just say I think this is an extremely important topic, and I appreciate everyone hosting this and attending. And we looked at hundreds and hundreds and hundreds of papers, and I was actually pretty surprised at how few just released their results. Sort of a basic thing like, can you download these results? How easy it is to just you can read their paper, but just sort of simple things like about data infrastructure, I think, are still lacking in a systematic way, and so. I think conversations like this are really helpful for coming up with like the future of science, which I think is coming, but we have to be there to make it happen if we want to have it.
And Patty, if you have any departing thoughts.
Yeah, and I think ultimately, like we've discussed here, I think a powerful force could be from journals themselves, from like a top-down perspective. I think unless they as institutions provide those as requisites for publication, which is just like the scientific, which is the currency of scientific communication, I think these changes might be very slow to actually take place.
All right, thank you so much.
And I'm glad to stay and answer a few questions in the chat. People continue to chat and it's still active.
I guess I'm not sure, I don't quite understand the meaning of this question, but while you're here, there was a question on if there are any comments on the undercounts, reliability, and the current issue with NHSN and COVID-19 hospital data.
Right. Yeah. So I think, I think that it's kind of a mess. There's a lot of inconsistency in the data that's reported in terms of testing, counts, hospitalizations, and even death attribution. And I think there's somewhat vague guidance given in some of these things. So different places interpret things differently. So I think it's hard. I think that makes it really difficult to interpret the data. And so in terms of the undercount, I'm assuming they're talking about undercounting cases. And I think one of the fundamental tricky things about any infectious disease is that there are mild cases that never get officially tested and so don't get counted. So there's always going to be an undercount there. But I think even in the case of COVID-19, there's other undercounts that are inconsistent from place to place that are pretty serious in interpreting even the official cases, because of the PCR tests are the official molecular tests, but then the antigen tests also measure active disease intermolecular, and CDC is not really clear on how those should be handled. So different places handle it differently. So some states include them in their case totals, some do not. And with antigen tests being increasingly used, I think that there's potential for us to lose track really of the pandemic. If the antigen tests get increasingly used and those don't start getting reported consistently in the cases, we're just not going to have a clear sense of the case counts. And that can also affect hospitalizations to a degree, since COVID-related hospitalizations typically require a positive test to count as a COVID. So again, how that's being handled, if that varies from place to place, that also, threatens the sort of the integrity of the data and the ability to interpret it properly.
And there has also been a lot of reference to something known as Zenodo.org, which seems to be a open air project in the vanguard of open access and open data movements in Europe. Was commissioned by the EC to support the NASA open data policy by providing a catch-all repository for EC-funded research, CERN, an open air partner, and pioneer in open source, open access, and open data to provide the capability of Zenodo. While you're here, is this something that you're familiar with regards to open data?
No, it's not something that I have personal experience with, but I guess in the sake of sharing other tools, I recently happened upon this package called Orderly in R, which is currently being used by the Imperial Modeling Group for their COVID efforts. And this, I think, is a really interesting addition to Git, which has kind of the limitation of being able to track the interaction of both like packages, code versioning and data versioning. So what this package seems to do, I haven't played with it fully yet, but it seems to track and version all versions of inputs, code, and outputs, so you can easily see how small changes in each step of the process changes the output ultimately. I thought that was a really interesting kind of concept and tool.
Thank you.